Okay, hi everyone, we're live and thanks for joining us. Sorry that we're a bit late, we had to switch computers, but all is good now. So welcome to the last Neuro seminar for the summer. And today I'm really happy and excited to host Rita Goldstein. Rita is a world leader in the neuroimaging study of cognitive and emotional processes underlying human cocaine addiction. She's a tenured professor at the Department of Psychiatry in the Icahn School of, sorry, if that's how you say it, Icahn School of Medicine at Mount Sinai, where she directs the neuroimaging of addictions and related conditions, or NARC research program. Before that, she was a tenured scientist at Brookhaven National Laboratory, and she was the first psychologist to have received tenure at the DNL. She received a PhD from the University of Miami, and before that, her BA from Tel Aviv University, and she received multiple awards, which I will not list here because it will take quite long. So really happy, really happy that Rita, that you joined us today, and thanks for joining. Before we start, I'll just remind all of you guys of the control features of Crowdcast. So on your right, you have a chat where you can ask any question that you like, or post links, or voice your enthusiasm, or anything that you want. And if there's some burning clarification questions, I will refer them to Rita during the talk. For slightly deeper or more talks that you might want to discuss with Rita at the end of the talk, please use the Ask a Question button at the bottom of the screen. And if you ask a question, I will invite you to ask your question, invite you to the screen to ask a question at the end of the talk. If you prefer that I ask the question for you, if you prefer not to be asked, not to go on screen, please state that in the question. Great. So with that, and without further ado, Rita, thanks for joining, and the floor is yours. Thanks a lot.
Okay, thank you very much, Alon, for this wonderful introduction and for inviting me. And hi, everybody. I don't see anyone, so I only see little circles. It's going to be a test for my ability to talk in a void. It's completely devoid of any social cues. So please bear with me if it's a little off, okay? And I'll stop after every few slides to ask questions, but then again, I'm not privy to this side for questions, so because I'm only going to see my slides from now on. But feel free to ask questions using this form. Okay, let me share my slides. That's great. Okay, can you see it?
Yeah, it's good. Exactly. Just go to present. Yeah, perfect.
Okay, wonderful. Okay. So again, thanks so much for the invitation, and we probably will end a little after 11. I planned for an hour, around an hour, including Q&A, but you know, whatever works. So these are statistics from the US of people who have used drugs in the past year, from 2016, if they are 12 years or older. And you can see how marijuana, the drug, basically pot, is used by many people. So this is almost 14% of the US population, almost 40 million people. And then we study cocaine in our lab, and it's used by around 2% of the US population, so about 5 million of individuals. And heroin, you can see on the bottom, which is used by around 1 million of people in the US. And I want to acknowledge the heroin epidemic, at least, again, those are numbers from the US, and you can see across time how heroin use has increased from 2002 to 2016. There is a twofold increase in heroin use, and it does not explain the huge increase in heroin deaths in the same time period, which actually jumped by sixfold. And this is because of synthetic ingredients such as fentanyl, probably. Now, if you compare people who actually have heroin use disorders, so people who use drugs, you can see how many millions there are there. But I'm going to define it in a minute. Use is not the same as a drug use disorder. So these are people here now, again, in the US, from 2002 to 16, at the age of 12 or older, and you can see increase of use of heroin, especially in the 18 to 25 years of age. And if you compare it to people with cocaine use disorder, you can see how it was much higher than that in the earlier year, 2002, and peaking in 2005. And then it's going down in that age group and still surpasses heroin use. So there is still a lot of use of cocaine. There are many people with cocaine use disorders, and cocaine is also #1 drug, surpassing any other drugs, including marijuana or heroin, that end up, that basically is associated with rates of emergency department visits. So if a person ends up in the ER, cocaine is #1 explanation for those type of visits. But those are numbers from 2011. There were no more recent ones. And I just wanted to show this slide that I just found yesterday. And this is from 2000 up to 2017. Again, just to remind everybody that cocaine is still very much a problem. And those are rates of drug overdose deaths involving cocaine in the US all the way up to 2017. And on the left, you see with opiate use, and on the right, without opiate use. And you can still see that type of increase that people forget about, that is recent. And now with the COVID epidemic, clearly there is an increase in overdose deaths from all drugs, including heroin and cocaine. Okay, so, but drug use and even drug abuse, so binging or weekend very heavy use, or bad habits that we all have, or even drug dependence are not drug addiction. And drug dependence is when you need the drug, more and more of the drug to reach the same effects. And if you stop using it, you will have withdrawal effect. Even that is not a drug addiction. So only in addiction, you have this constellation of loss of control of drug use, the amount and frequency of use, despite catastrophic consequences to your life, and despite a decrease in pleasure derived from the drug. And those are just a few examples of some of the books that really portray the phenomenology of addiction that can impact very bright individuals. And those are actually all Americans, but I'm sure you have your own share. It's not a national problem, clearly. So we emphasized that in order to understand the clinical symptomatology of addiction, we have to think about impairments in response inhibition and salience attribution to understand this chronically relapsing nature of addiction that has to do with intense craving for the drug, binging of the drug, and withdrawal that can be so severe as to lead a person back to drug use despite the best intentions not to use. So we expanded in this view of these impairments, of those neuropsychological impairments of self-control and emotion regulation. We expanded the view of addiction beyond the usual focus on subcortical, mesolimbic, nigrostriatal, dopaminergic involvement in reward processing and habit formation, into the prefrontal cortex role, the higher order cognitive functions, the executive functions, and thinking about specific roles of regions such as the orbitofrontal cortex, the cingulate, and the dorsolateral prefrontal cortex. Our approach in the lab is very comprehensive, and we really target very basic function in terms of behavioral, cognitive, emotional, personality function of our subjects. And we're also very lucky to be able to use the imaging tool, the imaging modality that we need to answer the question that we ask at that moment. And today I'm going to talk about EEG results and about MRI results. Our subjects are people who are smoking crack cocaine for about 20 years, for about 4 days a week. They're mostly males, mostly African American, in their 40s, with high school level of education and an average intellectual functioning. And they represent the Northeast urban area, the New York area, basically. We match them to healthy control subjects on as many demographic variables as we can, with the exception of variables that are part of the phenomenology of addiction, such as other drug use, such as cigarette smoking, which is very pervasive in our populations, and the other mental health issues. And those, we either try to match them or we study them, we target those measures to understand their impact, or we statistically control for them. Okay, so how do we get our subjects? I wanted to talk a little bit about that because it's actually a huge effort on our part, on my lab's part. We do a lot of recruitment using flyers, word of mouth, newspaper ads, that's very clear. But also we establish collaborations, working close collaborations with treatment centers. In New York, there are many of them. And those are essential to conduct this type of within-subject longitudinal studies. And I'm going to present here results of imaging studies that were done at baseline. So this is 3 weeks after a person is detoxified, about 3 weeks. And then we get them back, they come back to our lab 6 months later, and we can look at test, retest, and the effect of basic abstinence. So at follow-up, all subjects reduce their drug use, and we monitor it in many, many different ways. Do you see the slides okay?
Yes, all good.
Okay.
Yeah.
Okay, so we have, I'm going to talk about 5 hypotheses or 5 kind of themes in the lab, and I'll break every time. I'm going to go to a different theme as an opportunity for people to ask questions, okay? So the first theme and the first hypothesis is that people with addiction will show cognitive impairment, and it will be associated with the prefrontal cortex. So this is this slide is actually results from a different group, not our own, but it summarizes very well results of many different labs. It's a very reliable result across different drugs of addiction. When you compare people who are healthy individuals to people who are addicted to any type of substance on gray matter, and this is here we're using just T1 scans, and we're using voxel-based morphometry. So here we are, every voxel is assigned a probability of belonging to a certain tissue class, such as gray matter, white matter, or CSF, based on intensity and prior probability maps. So when you compare cocaine, drug-addicted individuals to healthy controls, you see a reduction in gray matter in this region here, the ventromedial PFC, in people with addiction. And this reduction in gray matter is associated with decision-making. So this is performance on the Iowa gambling task that assesses the person's ability to choose advantageously, meaning that they have to choose a lower reward for going a larger one in order not to lose the more they play those decks in this game. And you can see that people with addiction, first of all, they are usually playing bad on this task, so they make disadvantageous choices. They go back constantly to check those high gain cards. And the lower the gray matter in this region here, the more playing bad cards over time. So the hypothesis here is that this type of neuropsychological functioning, this type of decision-making, underlies the inability to forego a drug-related reinforcer, even despite of catastrophic consequences to an individual's life. And this is associated with reduction of gray matter, of the actual morphological integrity in this brain region. So in our lab, this is Nelly Alia-Klein, she is a co-chief of the lab. We showed the same type of reduction in the orbitofrontal cortex in people with cocaine addiction. And it was not only in the orbitofrontal cortex, I'm showing you here that, but we also seen the same results in the dorsolateral prefrontal cortex and other regions. But here we showed also a correlation with lifetime years of cocaine use, such as the longer, the more chronic the years, the time of cocaine use, the lower gray matter in this region here. And this is unique with cocaine in the OFC, but we can see the same correlations also with other regions. So for example, the hippocampus shows us the same correlation with cocaine use, but also with alcohol use and years of smoking. So this is only a correlation, and our tendency is to immediately assign causality and say, oh, drug use, cocaine, all of these drugs cause decreases in the gray matter in these brain regions here. But this is a correlation. We all know we cannot assign a causality because maybe there is another factor that actually contributes to both of these factors. So both a decrease in gray matter and the propensity to use drugs over the years. And maybe it has to do with genes. And we showed ourselves the importance of the monoamine oxidase A gene. I'm not going to go into that right now. We also showed the importance of childhood maltreatment. And so those factors, there is also nicotine, exposure to nicotine in utero. So we know several factors that predispose an individual and increase their risk for drug use in adolescence and then to becoming addicted and then also to relapsing after abstinence. So those predisposing factors are there. But still, so we cannot assign causality, but we can say, okay, if we can somehow curtail a person's lifetime years of use, maybe we somehow can persevere the integrity of those brain regions that are so important to value assignment, to extinction of memories that are no longer relevant. So, but to go back to the causality issue, in neuroimaging, in human neuroimaging, it really is impossible. You cannot assign a person here, you're going to be addicted, you're not, and let's now test some of our hypotheses. So that's not possible. But the way to go around it, one way is to do within subject type of studies. And here, that's the test Rita study that I mentioned, where we scan individuals at baseline, 3 weeks after detox, and then 6 months later, and we see gray matter increases in the same brain regions here, the inferior frontal gyrus, but also the ventromedial prefrontal cortex with abstinence. Those people are unique. It was a unique group of people who were able to be mostly abstinent during the 6 months. And it was associated with improvement in that task of decision-making, in the Iowa gambling task. So you can see here in the cocaine-addicted individuals, there were decrements on that task, as I showed you before, on the Iowa gambling task. But then it's after 6 months, you have an increase in that function. And they are now no longer different than the healthy control subjects. And there were also correlations between those increases, for example, in the inferior frontal gyrus from baseline to 6 months later, with performance on another higher order executive function task, the Wisconsin sort task. And the more the gray matter recovery in the IFG, the better performance on the task, the better the accuracy, and the lower the percent of perseverative errors, meaning that the people have more flexibility when they are performing this task. And clinically, what it means is that this selected group of subjects may, because of this gray matter increases, they were associated also with an increase in their ability to make advantageous choices and to show more flexibility on this shifting task. So maybe when they're outside the lab, they're also able to use those functions to then say, you know what, I'm not going to go to that place to use drugs, or I'm going to use alternatives to my usual pattern of using drugs under stress, for example. And by the way, this is Muhammad Parvaz. He was a PhD student in the lab, then a postdoc, and now he has his own lab that he manages at Mount Sinai. Beyond decision-making and shifting, if we look at other measures of cognitive function, I'm sorry, my mouse just makes it advance instead of showing you what I want to show you. So this is, we wanted to quantify the severity of impairment of cognitive function in drug-addicted individuals, and that was a study a while back. We didn't know, was there a general type of cognitive impairment in drug addiction as compared to healthy individuals? And then we basically have here 0, the mean of healthy control subjects, and those are cocaine-addicted individuals and people with alcohol use disorder, and we quantified their performance on visual memory tasks, verbal knowledge tasks, verbal memory, attention and executive functions, just classical neuropsychological paper and pencil tasks. And you can see that the level of severity of impairment is around a little bit less than 1 standard deviation below the healthy control mean. But if you compare them to people with schizophrenia, clearly in schizophrenia you have a much more pronounced cognitive decline than in cocaine-addicted individuals, or in drug-addicted individuals. But it's there, it's quantifiable, it's statistically significant, and it's clinically meaningful. So here is a study by another lab showing that the higher the cognitive function, the lower the odds of attrition from treatment, meaning that people with higher, more preserved cognitive function remain in treatment longer. And then we can, and if we can find ways to somehow increase cognitive function, maybe we can then intervene. We can have the opportunity, the window for intervention to help people reduce their drug use. Okay, so that was part one, and I'm gonna go now to part two, unless you have questions.
Yes, so there's one question which I think I'll just ask now. So it's a question from Charlotte. Does the smoking factor include the use of e-cigarettes too? Yeah, that's a question.
This study was conducted before e-cigarettes.
Right.
But yes, I would. My hypothesis would be definitely e-cigarettes can be as bad, if not even worse, in some respects. But we still need to study that. There are many studies now focusing on that, but it's in infancy. Okay, thank you for the question. Okay, so the next part of the IRISA model is that the salience of drug-related cues is pronounced. It's magnified. It's not just very much pronounced, but it also comes at the expense of reduction of the salience and value of non-drug-related cues. And all of that is associated with a compromised self-control. So in this study, I think it shows the best attention bias to drug-related cues. This is an ERP study. And here people are just passively looking at those images. The images can be pleasant, they can be horribly unpleasant, neutral or drug-related. And we quantify here from the scalp electrodes the late positive potential. So this is an event-related potential. So in the ongoing EEG, you can have positive and negative deflections that are time-locked to our event, and our event is just passively looking those pictures. And here in healthy control subjects, when you quantify the LPP, you are doing it in 2 time windows, early and later, and you also compare the pleasant images to neutral images as your control. And you can see in healthy control subjects a nice, robust arousal type of signal for these pleasant images. So the LPP is a bottom-up type of signal of arousal. And the same signal comes also for the unpleasant images. And the LPP does not differentiate value. It only shows arousals. Now, when you look at the cocaine images versus neutral, you see this LPP is basically not there. And if you look at those images, those little bags, right, and you're not addicted, you can think about little bags of sugar, little bags of flour, so they are not as arousing. But if you look at cocaine-addicted individuals, so the first thing that jumps to your eyes in this study is that type of arousal, both in the early and the late window when people with cocaine addiction are looking at those drug-related images. Another thing that was very important was what happened in the late window of processing both the pleasant images and the unpleasant images. So you have a decrease in the arousal for both, as if there is a premature habituation to something that's very arousing otherwise in cocaine-addicted individuals. So this is the same results that's shown a little bit differently. And again, so here we're contrasting the pleasant images to the neutral images, early and late window. This is a baseline, and now I'm going to show you what happens after 6 months of abstinence. So this is a baseline, and you see the reductions that I showed you before. But here at follow-up, 6 months later, you see a recovery, and now you have enhanced late positive potential component to those pleasant images as compared to the neutral, also in that second time window. In IRISA, as I mentioned, and the most important contrast is to look at what happens to people with addiction when you contrast something that's drug-related to something else that's really salient. So I think only this way, and very valuable, only this way we can understand addiction. So here we contrasted cocaine to pleasant cues, and this is at baseline, early window and late window, and there was more LPP, enhanced LPPs to the cocaine more than pleasant images in the drug-addicted individuals. But then after 6 months of follow-up, after 6 months of abstinence, you have a reversal. So it means now the processing of the pleasant cues is enhanced. And you have basically a recovery of their hedonic responses. Now, I'm presenting something very, very simple here in some ways. And keep in mind that I said recovery of hedonic responses, and I did not say, is there a change in their LPPs to the drug cues? I'm going to go back to that in one of the later slides, okay? But keep in mind that 6 months later, there is a recovery of hedonic responses. How else do we measure this type of cue reactivity? So we have the pictures. We can use many different reinforcers. Here we use something that's uniquely human. So we use words, and those can be drug-related or neutral words. And we also combined it in this task. This is in fMRI that includes also the salience of money. And it's real money, it's performance contingent, it's a salient task. But what you have to actually do on this task is ignore the money, ignore what you read, and just press for the color of the word, okay? So if it's yellow, you press for yellow. And that's the only thing that people have to notice is actually the color and pressing the right response for the right color. This is what they're doing in the scanner. Being a neuropsychologist in training, we take those classical neuropsychological tasks and we change them a little bit to fit our needs and our hypothesis in drug addiction. So here we changed that emotional Stroop, as I showed you, and here we also are changing semantic fluency task that we performed outside of the scanner. And so usually when you go to a neuropsychologist, clinical neuropsychologist, and there is a question about dementia or depression, one of the tasks that is going to be administered is the semantic fluency. It's a 1 minute, very short task, and you have to name as fast as possible, for example, as many animals as you can think. They can be from the farm, the jungle, the ocean, or house pets. And this task, where people just provide those type of animals or fruits or vegetables, is a wonderful executive function task of initiation, set maintenance, and then going back, maintain, and lack of errors, basically. So here, instead of animals and fruits and vegetables, we ask people to call to mind and name as many drug-related words as possible for 1 minute. And this could be names of drugs, people, places, or states of mind related to getting, using, or recovering from drugs. Healthy control subjects provided an average of 14 words correct, and cocaine-addicted individuals actually showed better performance. They provided more words. So, and thinking about that cognitive impairment I showed you before, so in that context of a decrease in cognitive function, on this task, people with addiction actually outperform healthy control subjects. This is their area of expertise. And if you look at it qualitatively, there are changes too. So healthy control subjects are providing words that are of drugs over the counter or type of derogatory terms to drug-addicted individuals, while people with addiction provide words that have to do with paraphernalia and how to use drugs. Okay, so then we can quantify this type of reactivity to this drug-related context by comparing the drug-related versus the neutral productivity of those words, the drug fluency. And we are controlling here for verbal IQ, and you can see how cocaine-addicted individuals have this hyperproduction in this drug-related context, and you cannot see it in healthy control subjects. But the interesting part in this study was that the same pattern of cue reactivity we saw on the drug Stroop task that I showed you at the level of the midbrain. So this is the brain regions where the cells that produce the cell bodies that produce dopamine are located, and if you stimulate that brain region, you will have dopamine release in other brain regions in the striatum all the way up to the prefrontal cortex. So, so what those results indicate or suggest is that those drug-related words, those drug-related cues, just the words that we hear and see and press for, evoke this potentially evoke this very conditioned response, very automatic, that maybe then is very hard to suppress. And so it may indicate not only goal-related type of motivated behavior, but also habitual type of automatic behaviors that are very conditioned and designate something as very salient. And we replicated this result now with another task, the emotional SSRT. We didn't publish it yet, but again, in a drug-related word context, just the words related to drugs, you can see the same type of response in drug-addicted, cocaine-addicted individuals, and not in healthy control subjects. So this is just to show reliability and replicability of effect. So it means when a person goes out there, they're of course not just surrounded by words and by pictures, but people with addiction, basically the context is constantly drug-related. So you can think about how then their behaviors can be guided in a way that is well beyond their control, especially that I showed you those decreases in gray matter in the regions that have to do with decision-making, with shifting, with flexibility and inhibitory control. So you have these bottom-up increases, but without the top-down ability to rebalance it. And indeed, on this drug Stroop task, we can see decreases in cocaine-addicted individuals in the dorsal cingulate that has to do with the ability to resolve cognitive conflict, and the rostroventromedial PFC that has to do with emotion regulation. And this is despite the fact that actually behaviorally, they did not differ from the healthy control subjects, and they were also matched on engagement and demographics. And still we see these striking differences in pre-FC regions. Okay, here is another time to ask a question.
So I think we have some questions, but I'll wait with them till the end of the talk. Yeah.
Okay. Okay. So number 4 that I wanted to mention is that impairments of self-awareness and insight into illness. And just starting with statistics, you can see here that this is who receives treatment. Past year, 2016, that's the latest we had. And you can see, okay, people with substance use disorder, so they meet criteria for a substance use disorder. They're not just using, above the age of 12. And you can see that 93% of them don't get any treatment. Okay, so most people with SUD do not receive treatment. And if you look at people with any mental illness, then you get people already start receiving treatment. Here, half of them. But also with serious mental illness, people, more and more of them starting to get treatment. But again, if you have co-occurring and any mental illness with SUD, again, 93% don't receive treatment, as if having substance use disorder somehow prevents you from getting treatment. It can be because of social factors, clearly, stigmatization, access to treatment, there are poverty, there are many, many factors. But one aspect maybe also has to do with the awareness of an insight into your own illness. And thinking about it, people with addiction, the most common descriptor of people with addiction is, oh, well, they're minimizing, they're in denial, or they're just lying, right? But coming from neuropsych, where I learned a lot before starting addiction studies, about schizophrenia and TBI and strokes and any type of neuropsychiatric illness, that insight into severity of your own illness is expressed in any of those disorders. So how come we are not studying it in addiction? And that's what we set out to do, and I wanted to talk just a little bit about that. And we designed a task to assess it, and this is a person sees these side-by-side images. They can be drug-related. This is a person simulating or use of crack cocaine, and this is a vicarious nice picture. We can dream about our vacations. And a person has to basically press for the image they want to look at, and if they press for it, it will enlarge, and that's what they will look at, and they have to keep pressing for it. It's basically keep working for it to keep looking at it, and that's what they're going to see. And then we have the implicit task. So this is where the contingencies are probabilistic. They're not that known to you when you play this task. We had the Iowa gambling task in our mind when we were designing it, and those are 4 different decks. And each deck, most of the cards that are stacked in each deck are mostly pleasant, mostly unpleasant, mostly neutral, or mostly drug, but you don't know it when you play it, because also the first few cards will be from different categories, and you have to basically press for this deck, and then it will flip over and you see this nice image, or you can either stay and keep choosing from that deck, or because you're a little novelty seeker, you want to see what's out there, you press for deck 2, and then, oh, this is my track image. Okay. So then people keep playing this task when they're not sure exactly what they are going to see. And we can quantify for the explicit task the total button presses. And these are pleasant, unpleasant, neutral, and cocaine images. And you can see that for people who are cocaine addicted, and here we're dividing them to whether they're positive for cocaine in urine, negative, or negative for cocaine in urine. The positive ones are you have used cocaine in the last 3 days. Those who are negatives used it 3 days and more, so they're abstinent. All of them are addictive. They meet criteria for substance use disorder, and you can see how, and they're not intoxicated. And you can see how people who are current users choose to look at the cocaine images more than people who are negative users and more than healthy control subjects. And although the negative users are still higher up than the healthy control subjects, and on the implicit task, the interesting part was that you first of all see the same type of choice towards looking at drug-related images, but you also see a flip for the pleasant images. So now healthy control subjects choose to look at the pleasant images more than the cocaine addicted individuals or abstinent or current users. So you have this flip of what it is that you want to just look at, the pictures you want to look at. So what does it mean? And here we can do some correlations with actual drug use and that type of choice, especially contrasting the cocaine to the pleasant images, so that contrast that is most meaningful to the IRISA model. The more the choices for the cocaine over pleasant images in the probabilistic task, the more the days per week of cocaine use in those who are treatment seekers, and the more just the total drug days. So that's the concurrent type of correlations. But the real interesting part was that it predicted use 6 months later. So here they're performing this task, cocaine more than pleasant, probabilistic picture choice. The people who are making that choice more, those who are choosing to look at the cocaine over pleasant images within subject, then they have higher total drug use days 6 months after performing this task. So this task has a reliability, we replicated it several times, and also validity, predictive validity. Okay, so, but how do we, so it's a drug-seeking task that is meaningful also to people's drug use outside the lab. But how do we quantify awareness beyond this choice, right? So because it's an implicit task, we can ask people after the task, what kinds of pictures do you think you chose to look at most often? And what we saw is that most healthy controls reported exactly what they chose. So there was a match between what they chose and what they said. But in abstinent users or the current cocaine users, there was no match. And the most very severe impairment was in the current cocaine users. So there was a split between what they chose to look at, which was mostly cocaine, and what they said that they looked at. And that was a measure of self-awareness we controlled for cognitive function statistically, learning and memory. Now, when we divided people based on that type of impairment, based on what I showed you, to impaired and those who were unimpaired and healthy control subjects, we saw this is an fMRI task of the color word Stroop. This is a very classical cognitive conflict type of task, and this is errors. This is monitoring errors in the rostral ACC. And you can see that those who are impaired in self-awareness awareness of choice on that task, on the choice task, had the lowest error monitoring in this brain region. And it was correlated with cocaine use. So the lower the signal in this region, the more the cocaine use days per week. And we also quantified their gray matter in this brain region, and they also showed the most decrease in gray matter in the same rostral cingulate region. So it means that this subgroup of individuals who have self-awareness impairment have this type of impairment in error monitoring and decreases in gray matter in this region as a function of frequency of use, and that maybe we have to treat those two groups very differently, because those who are unimpaired, they're still addicted, but we wouldn't target their self-awareness when coming to treat them. We would target self-awareness impairments in the other group. Okay, so what do we do about it? Well, you know, with all these impairments I spoke about that involve the PFC and all these different brain regions, what can we do about it? And being a clinical psychologist by training, this is something, and both of Cornell, it's something that's very important to us. And I'll show you 3 lines that we adapted in our lab. One is cognitive, just purely cognitive. And here we are doing cognitive reappraisal. And so people, drug-addicted individuals, healthy controls, are looking at those images that are drug, neutral, or very unpleasant. And then they hear a sound. And we tell them, okay, either keep looking at that image the same way you've been looking at it, or decrease your arousal to this image. And we ask them to reinterpret, not just distract yourself or avoid the image, but really reinterpret the image. For example, oh, this is not my cocaine, not my pipe. This is just a movie. I cannot really use that crack cocaine. And then, after they do that, we assess gaze duration. And we ask them to look at the screen as they wish, and we show them those images they've seen before from those 3 different categories, and a blank screen as a control. And we also assess their craving. Gaze duration is the time spent looking at one cue over the other, and cognitive reappraisal strategies have shown to reduce gaze duration to salient stimuli in healthy individuals. So what happens in our cocaine-addicted individuals? So first of all, and this is an ERP study, so the first result is that that type of reappraisal instruction decreased arousal as measured by the late positive potential in all subjects. So everybody, healthy controls and cocaine-addicted individuals, decreased their arousal, that type of bottom-up automatic signal, to drug-related images post-instruction. But the most important result here was what happened with their gaze duration. And only in the cocaine-addicted individuals, the individuals with cocaine use disorder, there was a decrease in the amount of time they spent looking at those drug-related images. Now, it's extremely important and significant because this was uninstructed. This is spontaneous behavior. We asked them to reappraise the image, and then we told them, just look at whatever you want to look at. It means that maybe cognitive reappraisal generalizes, and maybe it reduces spontaneous attention bias. How long it will last, and can we then generalize it outside the lab? Those are avenues that we're exploring. Okay, but we cannot only provide cognitive training to our subjects, right? Drug addiction is a lethal disorder. And you've seen those numbers that I showed you, and the rise in overdoses of young people. So we have to provide as many tools to people as possible. Here we used methylphenidate. Methylphenidate basically blocks dopamine transporters, increasing extracellular dopamine. It's basically Ritalin, what we give children with ADHD. It's very similar to cocaine in its mode of action, is just slower. Methylphenidate increases salience of food stimuli and math tasks in healthy individuals. It bolsters cognitive functions by improving signal-to-noise ratio and optimizing activity in the brain regions that are actually needed for accurate task performance. And although it's a stimulant, right, it decreases risk-taking and it improves inhibitory control in other psychopathologies that affect the prefrontal cortex integrity and function. ADHD I mentioned. We know how methylphenidate, Ritalin, and other similar drugs improve learning and ability to sustain attention. But also in those other frontotemporal dementia, TBI, and stroke, you have a decrease in risk-taking behavior. So our hypothesis was that methylphenidate will improve brain and behavior function, also in cocaine addiction, if administered at a low oral dose in the combination with the lab challenge. And if you think about other ways of interference with drug use in other drugs of abuse, so for example, in heroin addiction or nicotine addiction, interference with binding of the drug to the target, but slower pharmacokinetics is very valuable. So that was our guiding principle. So here, back to the drug Stroop task that I showed you before, where there were decrements in those prefrontal regions. And here it's a new sample, and here we're doing a counterbalanced, placebo-controlled, double-blind design in people with cocaine addiction versus healthy control subjects. Here, giving them placebo, and then a week later, methylphenidate, it's counterbalanced. And you can see that at placebo, there is that same decrease in the dorsal cingulate as I showed you before, but with methylphenidate, one dose, one time, you have no longer that difference with healthy control subjects, and the same happens for the ventromedial PFC. You saw that in placebo, there is that decrease, and it's no longer there under methylphenidate, and there was also association with an improvement in errors of commission, which is a common measure of impulsivity. I wanted to also mention that methylphenidate improved not only task performance, and we have it improving also the color word Stroop, dorsal cingulate, and DLPFC. It also improved connectivity, and this is resting state fMRI, so those are spontaneous synchronous fluctuations in the fMRI bulb. It indicates connectivity between brain regions in the absence of any stimulation. So they're just looking at the crosshair with eyes open in cocaine-addicted individuals and healthy controls. And you can see how this is the red is the healthy control subject. These are cocaine-addicted individuals at placebo. And this is with methylphenidate. You have higher connectivity between those two PFC regions that I mentioned, the VMPFC as seed and the dorsal cingulate. And it was not just an increase of signal overall across the board, which would invalidate basically our results, but it was very specific to the network. So here, when we seeded the nucleus accumbens, so the ventral striatum, where the nucleus accumbens, the hub of the what people think about as reward circuit, you can see that this is, again, the red was the healthy control subject. And at placebo, in cocaine-addicted individuals, you had hyperconnectivity between that nucleus accumbens region and the dorsal striatum. And methylphenidate decreased that hyperconnectivity to a level that didn't differ from controls. And that hyperconnectivity was correlated with more severity of addiction. So this is consistent with the thought that there is a spiraling dopaminergic type of connections through the midbrain that link the nucleus accumbens with the striatum implicated in drug seeking, and where the progression of addiction involves this type of shift from striatal circuits from the ventral to the dorsal type of networks. And indeed marking individual differences in severity, disease severity, meaning that maybe if we can weaken this connection, could we then restore control over drug seeking? That's an open question. Okay, so the last thing I'm going to show you is that we started doing in the lab. I showed you, okay, we are trying to intervene with cognitive tools. We're trying to intervene with pharmacological tools. And now we're trying to do something also directly stimulating the brain. And here we're using this device that sends a small direct current across the scalp to modulate brain function. It induces polarity-dependent alterations of cortical excitability. And in contrast to something like TMS, it actually one day can be taken home and used at home on an as-needed basis, if it works. It has been shown to reduce motor symptoms in Parkinson's disease and pain sensitivity in older adults with chronic pain syndromes, and it has been shown to reduce craving. So modulation specifically of the DLPFC showed in small type of studies, it reduced craving for cigarette smoking, marijuana, alcohol, and even food in healthy subjects. And looking a little more at the literature, which there was a group in Brazil by Esther Nakamura Palacios, who has done this type of sham control TDCS of the DLPFC with the anode being on the right DLPFC. So we're exciting the right DLPFC and reducing excitability on the left. And they administered it 5 times to people who are inpatients with cocaine addiction. And after these 5 times, you can see a reduction in craving in the real TDCS group as compared to the sham. This is the same result, shown differently. So then we said, okay, I presented to you results of rostral cingulate, VMPFC, dorsal cingulate. I did not present you result DLPFC, but all of these studies were targeting the DLPFC. So we thought back about our own review of the literature, where we reviewed all the fMRI studies that compared drug-addicted individuals to healthy control subjects. It was a very systematic review. And we showed that during drug Q exposure, you have enhances across all brain networks, including the executive network that includes the dorsolateral PFC. So this is when drug-addicted individuals are performing a drug Q type of exposure task as compared to healthy control subjects, you have these enhancements. So that's consistent with that salience that's attributed to the drug-related cues. But then when there are, in studies without drug Q exposure, you have decreases in all of those networks in the drug-addicted individuals. Again, it's that seesaw type of relationship between drug use and everything else in drug-addicted individuals. In our own fMRI studies, we also published abnormalities in the DLPFC, including the gray matter, but also functional abnormalities in cognitive control tasks, the color word Stroop, the emotional SSRT that I mentioned, and there was a rescue by methylphenidate I did not show you. So we went ahead and we completed this phase 1 pilot study. This is a postdoc in the lab who took a lead on this study. And basically, instead of 5 times of stimulation, we stimulated people who are inpatients in cocaine addiction centers. We stimulated them 15 times. And this is these are the number of subjects who started the study, and most of them actually completed. So we have complete data in 14 subjects, sham or receiving sham or real TDCS of the right DLPFC. And we show a trend for the reduction in craving, similarly to that other study in the real TDCS group only. We also showed improvements, significant, not just the trend, but significant improvements in sleep, daytime sleepiness, and quantity of sleep at night, and also contemplation of change. So clearly, we are actually now preparing to do a phase 2 study, doing the same, but with more objective measures, including those LPPs. Okay, so I'm just about to summarize, and I'll leave time for questions. We did start a little late, so. Okay, so let me just summarize what I showed you today. I spoke a lot about our model, the IRISA, the Impaired Response Inhibition and Salience Attribution and Addiction. I showed you a cognitive impairment and its association with PFC integrity and function. I spoke about effects of chronicity of use. I showed you both ERP and fMRI studies of attention bias to drug-related cues. And I spoke about modified neural sensitivity to non-drug-related stimuli, maybe premature habituation. We see the same type of impairments processing other type of reinforcers, including monetary reward. I did not show you that, that's published, and including deficits in reward prediction error. Again, it's published, I did not present that. There are similar results in alcohol use disorder, and those decrements are associated with craving. It's all consistent with the hypothesis that the value of the drug-related reward is increased, but that of non-drug reward is decreased, maybe because of adaptations to the supraphysiological stimulation by drugs. So you have a chronic dopaminergic hypo state in drug-addicted individuals. And then you have the drug cues that basically take all of that type of, all the salience comes from there. And if you have this compromised sensitivity to relative reward, and I did not speak about that concept, but it's very important to study, you will have necessarily impaired decision-making and impulsivity, depression, and anhedonia. And I did speak also about impaired insight and its importance to relapse prediction. Focusing on the abstinence and intervention part of the talk, I showed how reduction of drug use over 6 months period in initially treatment-seeking individuals is associated with normalizations of both structure. I showed you those gray matter PFC increases as associated with more advantageous decision-making and better executive function. And also improvements in function. So the salience markers of pleasant stimuli is increased. It may be associated with improved dopaminergic function. So again, drug addiction is associated with the chronically low levels of dopamine and dopamine receptor availability. But with abstinence, there may be recovery. I did not show you that. I showed you how cognitive reappraisal reduces drug-related attention bias. We definitely need to study it further. And methylphenidate enhances the PFC during different tasks that I did not speak about. I only showed you the drug Stroop task and the resting state connectivity. Could it be used as a cognitive enhancer? Could it enhance, for example, the cognitive reappraisal effects? Because cognitive reappraisal did not work for everybody, clearly. So can we enhance permeability of that type of cognitive intervention by using this dopaminergic type of agonist? I showed you also that TDCS has some promise. And again, the goal would be to find the people who would benefit the most from either one of those interventions, or from a combination of interventions, or from the right intervention at the right time. Addiction is a very, very dynamic type of disorder. So those results highlight brain plasticity even after chronic use of drugs. So think about it, those are people who are smoking crack cocaine, but also cigarettes and drink alcohol, and there is marijuana use. But still showing brain plasticity and suggesting that neuroimaging biomarkers could be useful in not only in tracking outcomes, but also maybe improving them. And I clearly focused on one region in a network at a time, only showing you that one resting state study. But we definitely have to study networks of brain networks and how they function together in drug addiction. So I want to end by complicating things a little bit, and again emphasizing the dynamic nature of addiction and how length of follow-up is really crucial. There is the concept of cue-induced incubation of craving in animal models. When an animal gets addicted, but then you discontinue drug use, it will keep seeking drugs. And that type of seeking of drugs actually increases as a function of time and withdrawal rate. And we showed it using those LPPs, those cue-induced LPPs. We showed it for the first time using an objective measure that the same phenomena happens also in people who are drug addicted. So as a function of time, you have an increase in cue reactivity. And this is despite the fact that the subjective self-reports are decreasing. So if you ask a person about their craving as a function of time since last use, they will report their craving is decreasing. But if you objectively measure cue reactivity, the picture is very different. This is cross-sectional results. We replicated it in another cross-sectional study, and we now have evidence for a longitudinal effect, the same. So the people who are scanned 5 times across a whole year within subjects show the same type of pattern. And think about it, with every type of desire, before it goes down, it first goes up. And with drugs, it's even more pronounced. So it means that whatever intervention we think about, we have to identify for the right person the right time to intervene, because that 1 month or 6 months time period where you have the highest cue reactivity, this is when people are discharged from treatment. and they feel in control. They have no craving, no perceived craving. But this may be the most vulnerable time for them in terms of relapse. So maybe this is the time we have to intervene the most. And this is just to, again, emphasize that the complexity of addiction. And we have a healthy state. In every person who is addicted, there is a healthy state. And you have this struggle between drug-related functions and non-drug-related functions, and associated with the ability to stop. Now, when you have craving and withdrawal, that type of balance between drug and non-drug is no longer there. It starts to change, and there is a lot of ambiguity about should I stop, should I use? There is a lot of then rationalizations and explanations about, well, maybe I'll just go there one time, maybe a little hit. And then during intoxication and binging, you have a complete flip now of functions that are drug-related, and they overpower the non-drug-related functions associated with the inability to stop that disadvantageous behavior. And I just wanted to mention, in addition to all those interventions, we're also now deploying mindfulness in heroin addiction. And I want to thank for your attention. And that's the lab in its earlier days in 2013 when we moved to Mount Sinai. And thank you for all of our support. And this is the lab now, minus a few people there. And thank you very much for your attention.
Okay, great. Thanks very much. That was an amazing overview of the years of work, and like very, very broad and very interesting. So there are some questions. I also have some questions, but I've invited Kylie on the screen. I don't know if we'll see if they come up, and if not, I'll ask the question for them. 1 sec, it always takes a bit of time. I might just close your slides for now so we can, yeah. Okay, I'll ask the question as I think they don't come on screen. So question is, hi, you talked about recovery of gray matter in the PFC after 6 months of treatment. I know it is estimated that the PFC can still experience neurogenesis or differentiation through a person's early 20s. I may have missed this. Did you see evidence of this critical period in your results? Was there less recovery in older subjects?
All our subjects are in the range is they're adults. We are not studying adolescents. But you know, the hippocampus can show neurogenesis, right? But in the PFC, the mechanism, of course, we cannot study it directly with our imaging, but with the animal studies, it's that those gray matter type of increases are associated with synaptic markers, growth cone indicators, dendritic spine density, and glutamate neurotransmission. In adolescence, for example, with alcohol use, when you use alcohol, it's clearly neurotoxic. The more alcohol used in rats, it's clearly neurotoxic. In human adolescents, alcohol binging is associated with decreases in gray matter in the hippocampus. And also, there is, if you prevent neurogenesis, hippocampal neurogenesis in animals, there is increased cocaine seeking. So you have basically this double whammy of alcohol decreasing neurons that are actually causing neurotoxicity at the hippocampal level, which then increases cocaine seeking.
Cool. And so I have actually a follow-up question on that. Yeah, like the mechanisms of this decrease gray matter.
So let me just tell one more thing is that I didn't mention a study, so the causality issue, right? So taking away that drug for 6 months abstinence, you see the recovery. And still, so it suggests that maybe abstinence increases that gray matter. But the ability to attribute causality came only after looking at the studies of a person like Charlie Bradbury, who's at NIDA, who can then assign non-human primates to receiving cocaine. And he shows that receiving cocaine, and there they can control for all these predisposing factors, all the complexity and the noise of human studies. And still, just receiving cocaine at the levels of people's self-administration reduces gray matter in those same regions, including the OFC, the PFC. And then 2 years of abstinence is associated with enhances of gray matter in those same regions.
Right.
And that's where we can say, okay, in addition to all the predisposing factors, there is a clear effect of cocaine on gray matter in the PFC.
Cool. And yeah, this might be a bit off topic because it's not, but do you know, like, do any of these effects also generalize to variations in healthy populations? So like along the spectrum of people who are maybe more prone to like habitual behavior versus a bit more like on the like kind of habitual versus goal-directed behavior, will any of these effects translate to that, or did anybody look at that?
So that study by Nelly Alea Klein in JAMA Psychiatry, it used to be called the Archives of General Psychiatry. Usually, when people look at those correlations, they actually separate healthy individuals from addicted individuals, and she did not. So she put it all together, and you see that correlations, including everybody.
Right.
And that's how she saw the correlation with nicotine smoking or with alcohol use. So it may be a spectrum type of issue. You can see it already. Addiction is clearly the severe expression of some behaviors that we all have.
Yeah.
Most of us try drugs. Some of us used it a lot. And most of us are not addicted.
Yeah. Okay, cool. Really interesting. So the next question, there's a question from Charlotte, who I have invited to the screen. So we'll wait for Charlotte to see if she comes up. It always takes a few seconds and it's a bit awkward. One sec. Yeah, there we go.
Oh my god, yeah, I finally made it.
Nice to see your face, in addition to lungs.
Yeah.
Oh my god. Yeah, I'm so sorry for if you think the question is silly, and I know it's a super sensitive topic, so I was really reluctant to ask it, but I've been working in a high-risk community housing with schizophrenic patients, and it's a community housing managed by independent team outside NHS, and most of them are addicted to several drugs at the same time. And so during COVID, my participation, I was shadowing a specialist, and it was brought to a abrupt stop. And so I tried different things. I tried initiating encrypted foreign conversations just to continue that, but they were really, really reluctant to technology, very resistant. And so I was wondering, I was really inspired by your Transcranial direct current stimulation, and I think that have a very longitudinal and inspiring effects. But did you find implementation difficult with people, especially from low socioeconomic background? Thank you.
So that's a great question, and we're starting now the phase 2. When I started the study, I was very skeptical, I have to say, but I wanted to try. I was really intrigued by the prior evidence, and now that we have very similar evidence, I'm very excited about continuing, but still getting some objective measures. I want to really see if it has effect on some objective measures of cure activity and how long it lasts, right? So this was a pilot study completed only in 14 subjects. We need many, many more subjects, and we need to assess how long would any effect on either craving or reducing cure activity or enhancing maybe some cognitive measure, the DLPFC and working memory or controlled retrieval of information. It has many different functions, inhibitory control. can we find those effects? When can we find them, and how long they will last? In terms of administration, it was actually pretty easy, and we are collaborating with Soterix. It's a company, and they have this trap. They trained us how to do it, and then we are training our patients how to do that. And I think after 3-4 times, a person can just put it on by themselves. So I think it is doable. If it works, it will be phenomenal. I'm still, I wouldn't be still the one to tell you, yeah, use it now. No, I think we need more empirical results before I can say it works for that type of person at that time.
Yeah, thank you so much.
Thank you for your question. Questions are never silly.
Yeah,
Thank you so
I'm a
much.
bit of an ethicist, so I just ask these things. Thanks so much.
Okay, thank you. Thanks, Sharon. Cool. Now I actually have one more question. It's about the last part where you were showing quite like striking effects about this kind of critical period of 1 to 6 months where people perceive that they're doing fine, but actually when we're not doing fine. It's very like seems like very strong effects and very clear. And I was wondering, I know nothing about kind of policy making of how of treatments and what you were saying. Until which point does the system support addicts and stuff like that? And I was wondering how easy it is for very, very striking effects like that to kind of permeate the policy making process, and where
That's a very good question. There is a gap. There is a huge gap between our results, not only ours, scientists' results, animal results, going to rodents, to humans, through all of it, and policy making, and treatment, and what's happening out there in actually rehab places, not to mention in courtrooms. Huge gap. And I think as scientists, we all have to be very much to put it as something that's really important for us, to keep communicating those results and their importance to the field. And that's why I constantly link it to clinical stuff when I talk about our fMRI midbrain results. Because really we need to change the minds of people, and it is being done. So for example, Nora Volko, who used to be my postdoc advisor at Brookhaven National Lab, and she's directing NIDA now for many, many years. At NIDA level, they do a lot of explaining, and still there is a lot of resistance perceiving addiction as a disorder of the brain, for example. There is still, it's a huge, now maybe the heroin epidemic, if anything, it's a horrible, horrible loss of life, just catastrophic. But the one silver lining there is that people are understanding that it can affect everybody and anybody, and it is a disorder. So maybe that can help with the policy making.
Yeah. Okay. Cool. Interesting. Okay, I think we're actually out of time, and there's one last question that just popped up. So I'll just invite Amir on the screen. So he'll be up in a second.
Hello.
Hello.
This works. Excellent. I had to sort of set lots of permissions very, very quickly. Thank you so much for your talk. So my question was, you showed a lot of data comparing healthy controls versus your sort of long-term cohort of cocaine-addicted subjects, showing how the salience is different. Do you have any data? I'm sure there is, and you'll know. Do you have any data of sort of recreational, non-addicted drug users and how they respond potentially differently to sort of drug-addicted subjects, which you seem to show? And what are the sort of pertinent differences between these two?
Yeah, it goes back to that other question, but we don't have that. Many of our control subjects, we don't exclude for recreational drug use. We exclude for meeting criteria for a disorder. So they use alcohol, marijuana, even cocaine. Some people can even use heroin recreationally, which is pretty amazing. But so there are a few studies that I saw that I remember that compare recreational users to drug addicted. And like I said, it looks to be on the spectrum. So you can see some of the differences already with healthy control subjects. Although it's not as simple as that. So for example, there is a study by Thomas Pausch a while back in JAMA Psychiatry where nicotine exposure in utero basically is associated with thinner orbitofrontal cortex in the offspring.
Right.
And that thinner OFC is associated then with experimentation during adolescence, but that was also modulated by a certain gene, which I forget what it was. But he makes the point, very clear point, that at certain time periods in human development, drug use is not all bad. And that it depends what it is that you're studying. And it may be indicative of like novelty seeking or, you know, so I don't want to preach or those results to be over-interpreted. And it's a very important field of study because some people have to be protected. Some people are at higher risk of addiction. And for them, it's better if they don't experiment. Just don't delay it until your PFC is mature. And that's actually, for every young adult, I would say that delay experimentation if you can.
Right.
Because you don't know if you are at risk. Some people, there is some protection there, and they can use, and they will not become addicted. Then again, when you use a lot, and even people who are protected can lose their protection. And because cocaine and those drugs have detrimental effects on the brain. So don't over celebrate the protection factors. And we don't know them yet. We don't know which group we belong to.
Okay, thank you very much.
Thank you.
Okay, thanks, Emil. That's really interesting and good food for thought for parents in the future.
Yeah.
Cool. So I think that our time is up. But once again, thanks so much for a really, really interesting talk and like an excellent overview of loads of amazing work. And yeah, and thanks everyone for joining. And see you soon.
Thank you, everybody. Bye.
Bye-bye.